Hi, everyone, and welcome to our project presentation. This is the demographic analysis of mental health care in the United States. My name is Tanmay Singh, and joining me are Zachary Johnson and Nawaf Alotaibi. In 2023, there have been rapid technological advancements and an ever-increasing emphasis on data-driven decision-making, and the mental health field is experiencing a transformative shift. Recognizing the profound importance of mental health, society is beginning to appreciate that emotional well-being is as essential as physical health for a thriving and harmonious life. Understanding and addressing mental health issues is crucial, not only on a personal level, but also for the well-being of communities and societies as a whole. Good mental health is fundamental to leading a fulfilling life as it influences our relationships, career success, and overall life satisfaction. It helps us tackle challenges in life better, enhances our innate, creative, and productive tendencies. The growing awareness and emphasis on mental health has led to increased recognition of its importance in overall well-being. As a result, the role of data scientists in mental health research is as large as ever. As data scientists, we have the tools available to find trends, patterns in the occurrence, recognition, and treatment of mental illnesses. The mental health care system in the United States is grappling with inequalities, which represent the picture of how people across the country deal or don't deal with mental health issues. They might seem like just mere statistics on the screen, but they represent communities and members of society who are struggling to obtain the kind of care they need. Some factors contribute to this issue, and the impact of these disparities profoundly results in treatments and support for those experiencing health challenges. These trends can be used to promote further change that ultimately allows everyone to receive the mental health care that they need depending on who they are as a person and what their diagnosis is. The dataset we use for our project contains results of the US Census Bureau's Household Pulse Survey between August 2020 and May 2022. Our objective has been to study the mental wellness of the US population through the lens of a demographic information that the census captures. The Census Bureau provides over 10,000 individual records and a wealth of demographic info about its respondents, including but not limited to age, ethnicity, economic status, sexuality, and education. With this supplemental information, we hope to discover which areas of the US population are experiencing mental health problems differently than others. Following basic data cleaning practices like removing nulls and dropping unrequired columns, we decided to study which demographic groups are over or underrepresented. In mental health treatment, we will be focusing on the estimates of subgroups divided by age, group, education, and ethnicity.
So to analyze the data, we decided to treat each subgroup as its own random variable, with the estimates from each survey period being sample values of that random variable. This relies on the assumption that the variables are independently distributed. In other words, the time during which the survey was conducted does not affect the result. So if this assumption holds, then according to the central limit theorem, each variable will be normally distributed about the population mean for that demographic group. To test the normality of our variables, we use histograms, QQ plots, and the Shapiro-Wilk test. You can see a histogram and a QQ plot on the screen. The histogram itself, along with the hypothetical normal bell curve of that distribution, and then the empirical density curve. If the variable is truly normally distributed, then the blue and the black lines should match up evenly. And then in the QQ plot, a perfect normal distribution would be represented by each of the points being perfectly along a straight line. The Shapiro-Wilk test tests the normality of a variable by providing a p-value. If the p-value is less than the level of significance, we would reject the normality of that variable. So we first looked at the data to spot general patterns, then we dug deeper, testing ideas. So we found out some key facts about the differences in getting mental health care between our demographic groups. We used box plots to visually determine these possible trends before performing a more depth analysis. Each box plot takes the distribution of sample values across the subgroups in each demographic category, and then the red line in the box plots shows the estimated US population mean. So looking at the distribution by age, we can see that the older age groups, specifically 60 to 69, 70 to 79, and 80 plus, the percentage receiving treatment decreases as the age groups get older. But we wanted to focus on the age groups from 18 to 49, or sorry, 18 to 59, where the distribution appears very similar. We wanted to determine if the mean for these groups was different or the same. Looking at distribution by sex, you can see a clear difference between females and males. We wanted to investigate exactly what the severity of this difference was and find out exactly how much more likely females are to receive mental health treatment than males. By race or Hispanic ethnicity, you can see that non-Hispanic Asian Americans are much less likely to receive care than the average American, as are Blacks and Hispanics. We wanted to investigate how less likely Asian Americans are to receive mental health care. We figured that this difference would be about 50%, or an Asian American would be half as likely to receive treatment as anybody else. We also wanted to investigate the similarity of the non-Hispanic Black and Hispanic populations. Looking by education, we saw that those with a high school diploma and those with less than a high school education also appeared very similar. We wanted to determine if these two groups were related or if there was a significant difference in their distributions.
Hypothesis testing. It's basically used to assess the publicity of a hypothesis by using sample data. We test a hypothesis by measuring and examining a random sample of the population being analyzed. After examining the distribution of our target variable against demographic information, we came up with a number of testable hypotheses for each of our chosen population characteristics. The techniques for testing that indicates two tests, which is Welsh F-test, ANOVA predictor, and p-value testing. Welsh ANOVA compares two or more means to see if they are equal. It is an alternative to the classic ANOVA and can be used even if your data violates the assumptions of homogeneity of variance. The ANOVA test uses a null hypothesis where we can compare the means of different and multiply sample sets of population. p-value are used in hypothesis testing to help decide whether to reject the null hypothesis, and this was done using two samples t-testing. Again, considering equal variance, lower p-value indicates stronger evidence against the null hypothesis, whereas p-value greater than the significance value helps us accept the null hypothesis.
So using these tests, we found some key findings. Looking at age, we determined that the age ranges 18 to 29 and 30 to 39 were very similar, as were 40 to 49 and 50 to 59. From there, we determined that the best grouping by age would be to combine those groups and then compare them. Looking at the population by sex, we estimated a 12% difference between the male and female populations. Looking at ethnicity, we did in fact confirm that the non-Hispanic Asian population is estimated to be half as likely to receive treatment. And then we did find convincing similarities between non-Hispanic Black and Hispanic Latino Americans. So we would like to further investigate the similarities between those two groups to figure out what makes them so similar. Looking at education, we found that non-college educated Americans with or without their high school diploma or GED had a similar likelihood of receiving treatment. So due to the smaller amount of observations available in our data set, only 33, further testing of the hypotheses that we found would be recommended. And although we cannot use the knowledge of who is receiving mental health care to draw assumptions about access to care or the likelihood of suffering from mental health issues such as depression and anxiety, the knowledge of which demographics are more likely to receive mental health treatment can help healthcare providers better allocate resources to those who are more likely to need them.
By reaching to the conclusion, our findings also promote further research into our underrepresented groups to determine why these demographics are more or less likely to receive help. Topics to investigate include social stigma about mental health that exist within certain demographics, better or worse, resource and availability of prescription drugs and counseling services and communication, and factors that lead to the development of anxiety, depression symptoms in the first place. By building off of our findings, we hope that our analysis can lead to the real change in the mental health field. In addition, our findings demonstrate the importance of data-driven analysis in demography and healthcare. Through the continued collaboration of data science and others in the mental health field, we can create healthier, happier communities. It is also important to recognize the fact that as a society, we are still quite behind when it comes to making mental health help more accessible and destigmatized, and we should consistently be doing more to make sure everyone who needs help gets help.